Hello, good evening. Hello, good evening to all of you. I am going to start chapter 1 today from 5 chapter 1, Forces and Motion 2. And then this is free tuition, right? So for January, it is totally free. And if you are interested to join, right, after January, so February start, then you need to pay. All right, the tuition fee will be 65 per month. If you are interested, all right, so ask your friend to join, right? Ask them to join and write your referral into your name. And every month you will enjoy 10 ringgit rebate. Okay, so before we start, all right, I am Mr. Lee. So I have teaching physics for past 21 years. So we are going to start lah. All right. And my camera is not working today. I don't know why. Just now I see still okay, but now it is not working, so you cannot see my face. I try one more time, see whether it can work or not. No, it is not working. Right. My camera still holiday. Alright, so let's start. So we go for chapter 1, Forces in Motion 2, 1.1 Resultant Force. So you need to know what is resultant force by memorize the definition. So single force that represent the vector sum of two or more forces acting on the object. So not only one, right? Can be 2 or 3, but outcome it is just one single force. They represent the many force act on the object. So this is called resultant force. You need to memorize. So first of all, if the force normally we put it 10 Newton to the left, 10 Newton to the right. So this one, we call it the resultant force is 0. Because we normally use the right one minus the left one. Right? 10 minus 10. 10 minus 10, the resultant force, it is 0. So we call it as equilibrium. Equilibrium. So when it is equilibrium, what you can see is the object is not moving. Or we call it stationary, not moving. Right, not moving, or when it is moved, it will move with constant velocity. Right, constant velocity means acceleration it is equal to 0. Okay, constant velocity, acceleration 0. When you see the word of equilibrium, so it must be not moving or moving with constant velocity. What if the force it is not this one we also can call it as balance force because the force to the left and right it is the same. All right, so when the force to the right it is 15 Newton, left it is 10 Newton, so this resultant force is not equal to 0 already. All right, so the object will accelerate. Why it is accelerate? Because we got a resultant force. So we got a formula F is equals to ma. Alright, so this is the resultant force. When the resultant force is not 0, mean you got an acceleration. So the force to the right, it is more than the left. So the object will accelerate to the right. Okay, so 15 is more than 10. So how much is the resultant force? If you want to calculate, it is 15 minus 10. Alright, 15 minus 10. Alright. So how about this one? All right. So the 15 to the left and then 10 to the right. So this one, it is not equal to 0. So the object will accelerate. But normally, you are going to take this one, 15 minus 10. All right. So some of you will take 10 minus 15 is my resultant force. Right. Negative 5. No, we don't take negative. All right. We don't take negative. We just take it as positive. All right. So the object will accelerate. So we don't take 10 minus 15. Now we take 15 minus 10. Right? Is your resultant force. Okay. Now the object will go to the left because the left it is more than the right, the force. Right? So the object will accelerate to the left. So now we are going to use this formula. F is equal to ma. Right? F is equal to ma. What is F? F is called resultant force. But if you want to call it as you don't want to call it resultant force, you can call it as just force, right? Force. Or you don't want to call it resultant force, you can call it as net force, right? Also can. Right? Net force also can. But resultant force, it is more correct because of resultant force take in the direction. Right? We are gonna see. Right? But maybe not today. Maybe it will be next week or next week. So m it is mass of the object in kg. Acceleration a, right? ms negative 2. All right. Now, first of all, we are going to see the situation number 1. Determine the resultant force. All right. So if the same direction, we plus them. Same direction, we just plus. Because of this one go to the right. 10 Newton go to the right. This one also go to the right. So 10 plus 5, you just plus them. Right? Same direction. If opposite direction, right, you minus. We use the bigger minus the smaller. Right? If this one 15, this one 10, all right, 15 minus 10. Use bigger minus smaller one. All right? Next one, if the direction is this perpendicular to each other, what do? Right? So you need to use the Pythagoras theorem. We are going to see it not today. Right? We are going to see in detail maybe next week lah. Right? And then if the direction it is not perpendicular and then it is not opposite, not same direction, it is like random direction, there is an angle. So you need to use sine rule or cos rule to solve this problem. But this one very seldom come out lah. Right? This kind of question very seldom come out. This one you are going to learn into detail in your maths, additional mathematics, sine rule and cos rule. I don't know whether you learn it or not. Right? Last time it is in form 4. Right? But now I am not sure. Right? The new syllabus I am not sure because I don't teach maths already. Okay, so we look at the example number 1. So first of all, you need to see what is this. This is smooth surface, right? So smooth surface, you don't need to copy anything. Just listen, right? Will be enough because the notes I will send into the group later, right? Smooth surface mean no friction. No frictional force. Right, the frictional force is equal to 0. Right, nothing to stop you from moving forward. Okay, so now if this kind of question, when you see smooth surface, so mean there is no friction. All right, what if you got friction? We are going to see later, not smooth surface one. All right, like for example, rough surface. All right, later. All right, not now. So we see now easy one without frictional force one. So now first of all, what you need to do is F is equal to ma. So this formula is F is equal to ma. So what is this F? This F we can call it as resultant force or net force, right? Like what I told you, resultant force. But normally I am not going to write the resultant here. But now for the first one, we are going to write resultant force, right? Is equal to ma. So what is the resultant force here? It is 15 minus 10. Right? Big minus small. 15 minus 10. Is equal to m. M is mass of the object in kg. Make sure it is in kg. If this one it is in gram, change it to kg. Right? 2. Right? Acceleration, I don't know. So acceleration, they ask you, find the acceleration of the object. So A, I don't know. So 15 minus 10, it is 5. Is equal to 2A. 5 is equal to 2A. So how much is A here? A gonna be 2.5. Alright, 2.5. What is the unit of acceleration? ms negative 2. Right, make sure you write the unit correctly. If you don't write the unit correctly, so this one you short of 1 mark. They will deduct, they will minus your mark, 1 mark here. Alright, F is equal to ma. So very easy. Now find the acceleration, hence state the relationship between the mass and acceleration. So there is 2 questions here. So first of all, what do we do is F is equal to ma. I'm not going to write the resultant force here already. Just write F. Right? F is how much? 15 minus 10. 15 minus 10 is equal to ma. M it is 5. Right? 5. 5a. So 15 minus 10 it is 5 is equal to 5a. So a gonna be 5 divided by 5. A is equal to 5 divided by 5. It is 1. 1 ms negative 2. Is that okay? Alright, 1 ms negative 2. So now in these 2 examples, what can we see? 15, 10, 15, 10, same. Smooth surface, same. Once it is lighter, faster. Acceleration is bigger, 2.5. One, it is heavier. One, it is big. Right, the mass is big. So what happened? The acceleration become 1. So state the relationship between mass and acceleration. So mass and acceleration terbalik. Okay, we call it inversely proportional. Mass is inversely proportional to the acceleration. Mean the bigger the mass, the smaller the acceleration, terbalik. Okay, we can see from the formula F is equal to ma. Right, this one, the both example, it is the resultant force, it is the same, 5. Right, 10 15 minus 10, 5, same. Right, this one same. So when this one big, mass is big, this one is small. Right, when they multiply time together, so they will be inversely proportional. Right, so you need to know this. Inversely proportional. Okay, now we see other example. Like for example, I don't give you what is this F and this is 10. So find the value of the F. It is if the 3 kg object is accelerated with 2. So what's the formula? Same thing. F is equal to ma. F is equal to ma. F, now you can use F minus 10. Alright, F minus 10. This F is not resultant force. This F is here. This F. F minus 10 is equal to ma. 3a. What is the A? A, it is 2. Or I don't know which one. Alright, you can use 10 minus F is equal to ma also. Right, we are going to do it later. So we got 2 answers. But normally we are going to take the F bigger. Right, F bigger minus smaller. So I'm going to take this one F as bigger one. Right, so but never mind, we are going to do this one first. Right, F minus 10 is equal to 6. So you bring the 10 to here, become plus. Right, 6 plus 10. So F is equal to 16. Right, F is equal to 16. Or it can be another way around. Another way around means the object, it is going to accelerate into this direction. So they never said accelerate to the left or right. Okay, so it can be both. So we redo. If this object accelerate to the left, what will be the answer? F is equal to ma. F is 10 minus F. Bigger minus smaller. So I take F 10 here minus F, because of I take this one bigger, it go to the left. Right? So F 10 minus F is equal to ma. M, What is the mass? 3. A it is 2, right? So 10 minus F is equals to 6. So I'm going to bring the F into here. This F, negative F, I bring to here, become positive, right? Positive F. So this 6 is positive, I bring to here, become negative. So 10 minus 6. F is equal to 10 minus 6. Which is F is equal to 4 Newton. So it can be both answer. Alright, I don't want. It can be this one or this one. But my answer, I am putting this one only. Alright, when I set this question, I forgot it can be go to the left. Alright, okay, both can, both can. Alright, so we continue this kind of question. Now, this kind of question, less likely will come out in SPM because it is kind of hard, right? But anyhow, I am going to teach you how to do this by using calculation. But in SPM, normally you are going to use measure, right? Use measure, right? So measure, very hard to come out. So I just take one example only lah. So now this one, it is 90 degree. You can see this one is 3 and 4. It is 90 degree, right? What is this 90 degree? Okay, you can see here. This one is 3 Newton going up and 4 Newton going to the right. So it is 90 degree perpendicular. So magnitude of the resultant force by help of drawing. Okay. Now A, you need to draw this. They ask you to draw, not I ask. They ask you to draw, right? So when they ask you to draw, so you're gonna have here. Okay. Actually you draw 2 only lah. So I draw extra one, right? Because of later we are going to continue, right? So first of all, you need to draw this one only. This one and this one. Right? This one is 3 Newton. This one is 4 Newton. Right? 3 Newton and 4 Newton. So 3 Newton, here we are going to use a number. Right? For example, 3 cm. Or multiple of 3. 6 cm also can. If this one is 6 cm, so this one going to be 8 cm times 2. And if this one 3 cm, so this one 4 cm. So I'm going to use drawing here. You can see. Here it is 3 cm. Here it is 4 cm. Right? So this one is 3 cm. I label it first. So after that, you need to do a parallelogram, or for here it is rectangular. Right? Rectangular. So here also 3 cm. Sorry. Here also 4 cm. Same as here. Parallel. Here also 3 cm, right? 4 cm, and 3 cm here. So now this one is your resultant force from here where we start to where we end. Right? You look at the arrow here, right? The arrow from here to here. So the error here also very important for your resultant force. So you need to know. So the resultant force here is, we normally use 2 errors for the resultant force. So I am going to label the resultant force here. The resultant force here, I'm going to name it as FR. Right? Result. F, then resultant force. Right? FR. Resultant force. So this is my resultant force here into this direction. Magnitude of the resultant force, so we need to calculate it. So this one, it is triangle. You can see this is a triangle, so we use Pythagoras theorem to calculate it. Okay, so FR gonna be, resultant force gonna be equal to 3 square plus 4 square and then square root. 3 square plus 4 square, and then whole thing, it is square root. right? So square root of 3 square plus 4 square, you're gonna get 5 cm, right? Not Newton, not Newton yet. So we know that 3 cm represent 3 Newton, 3 cm represent 3 Newton, 4 cm represent 4 Newton. So what is the resultant force? You can straight away answer here. The resultant force will be equal to 5 Newton. So you re-answer. Resultant force is equal to 5 Newton. Right? 5 Newton. That's all. Right? I bring this one to here. Wait. Resultant force will be 5 Newton. So magnitude of the resultant force by help of drawing. So I draw everything in and then I calculate. Right? So now direction of the force. So when it is direction of the force, you need to calculate this angle for me. This angle for me. So I'm going to put this one in. Right? This one I call it as theta. Right, this angle I'm going to call it as theta. Alright, so B I want to calculate the angle here. Angle here will be tangent theta. Alright, so this one we're going to use tangent. Tangent theta is equal to, tangent is opposite over adjacent. Opposite over adjacent. Opposite it is 3. Adjacent it is 4. 3 over 4. So we need to use calculator. Where is my calculator? Well, I lost my calculator. 1 minute. Here. So long not using it, so it is not in my shortcut already. Okay, after one holiday. So now want to find theta. So 3 divided by 4 equal first. So here, so you want to get rid of this tangent. So you shift tangent equal. So 36.87. 36.869. So we round off to 87. Theta is 36.87. Unit is in degree. So this is the direction of the force. Now here, C. They are asking me about the acceleration if it is on smooth surface, right? So acceleration is F is equal to ma. F is equal to ma. F, how much is the resultant force? I have calculated it is 5 Newton. 5 is equal to ma. M 3 kg. A don't know. So 5 divided by 3. 5 divided by 3. Answer is 1.67. Unit is ms negative 2 acceleration. Unit is ms negative 2. Alright, so this is the answer. This kind of question will be less likely to come out in SPM because no place to ask you about this kind of question. Alright, so you no need to focus into this one. Alright, so we go quickly to example number 5 to see what if the object here you apply a force into the rough surface. Rough surface means got friction. There is a friction, right? So now the friction always against the movement of the object, always against the resultant force, always against. All right, meaning that if your resultant force, your force is from here, so your friction will be here. This is your friction. All right. If the object is here, you got a force applied it to here, so this one will be your resultant force. Now, not resultant force. I'm sorry. Your frictional force. Frictional force. Right. So if you go to higher level, the frictional force, the formula, there is a formula. So the formula is mu r. Mu r. This one is called mu. This one is called reaction. But because of you don't go to higher level, so I just called it as senang sikit. I normally write my frictional force as mu. Right, mu is my frictional force. Next time when you see I write this one, that one is my frictional force, mu. All right, hopefully you know. So this one is my frictional force, right? So I'm going to write it here. Right, frictional force. So I'm going to use the symbol of mu. Mu is here. Okay, mu. So find the value of F. I don't know how much is F. The mass is 2 kg. It's moving at constant velocity 3 ms minus 1. Given the frictional force of the rough surface is 10 Newton. Alright. So this kind of question. Now next time when you see the object is constant velocity. Constant velocity, yeah, you no need to see how much is this value. When constant velocity, so they said the frictional force is 10, so the force here will be 10. Yeah, meaning that here it is 10, so here will be 10. Why? Okay, why? I will explain to you why later. I will do it for you. I'll calculate for you. But I want you to know when you see this kind of question, right? When you see constant velocity, what is constant velocity? Constant velocity mean equilibrium. Okay, we go back to what we have learned just now. Right? Constant velocity mean left and right will be the same. Constant velocity mean equilibrium. Equilibrium mean left and right will be the same. Left and right will be the same. Okay, left and right will be the same. So meaning that this kind of question you no need to do. You also can write the answer. Now the F is 10 here. So this one is 10. This one is 10. So the F gonna be 10. Right? But calculation how, Cikgu? Calculation. I want to prove it. Yeah? No problem. So let me prove it for you. Right? F is equals to MA. F is equals to MA. Resultant force is MA. Resultant force is F minus mu. F minus mu is equals to M is to A. How much is A? A is 3, Cikgu. No. This one is not acceleration. Acceleration is ms negative 2. This one is constant velocity ms minus 1. So the velocity for constant velocity, the acceleration, it is 0. So we know the frictional force, it is 10, right? F minus 10 is equals to 0. You bring the 10 to here, so F gonna be 10. F gonna be 10, right? F gonna be 10. I am going to show you a video on how it is work, alright? No worry. So now you can just write F is equals to 10 Newton, that's all. Right, but side here I calculate the full one for you to show you what is F is equals to MA. F is F minus mu is equals to MA M3 times 0. Alright, F minus 10 is equals to 0. F is equals to 10. Alright, this is what we have. I show you once only. Next time we are not going to do it. Okay. Now, I will do example number 6 later. Now I am going to show you a video on what is the resultant force. Okay. Give me 1 minute. I go and look for my my past video before. Okay. My video previously. So I got a calculator at here. We are going to see what is frictional force. Mozart-Lee, this is rough surface. Rough surface, I tie a string on here at the back of the calculator. Let's say the frictional force is 5 Newton. I tie a string here. So we see what happened. When I pulled it, what happened? If I pull less than 5 Newton, then it is not going to move, right? So I try, force apply, less than the frictional force. Force apply here, 1 Newton, not moving. Because the frictional force is 5 Newton. 2 Newton, no. 3 Newton, no. 4 Newton, then 5 Newton, then it starts to move. Once it moves with constant velocity. So meaning that at this moment, here, I am pulling with 5 Newton, where the frictional force is 5 Newton. So this one, we call it as equilibrium. It starts to move. If I pull with 4, it is not going to move. 3, not going to move. Because let's say we got a frictional force of 5 Newton. So I pull with 5, it starts to move. Right? What if I pull more than 5? We are going to see it later lah. So constant velocity. Right? So the frictional force is 5 Newton. So now you see, now just now the question is, they said the frictional force is 10 Newton. The question said frictional force is 10 Newton. So when you pull, the question said it moves with constant velocity. So how much is the F will make it move with constant velocity? What do you think? What do you think? How much is the force that will make it move with 10? You move with constant velocity. Of course, have to be 10, right? If you pull with 9, it is not going to move. Am I right? So when you see the word of constant velocity, you don't need to see, right? No need to do, right? Just same, right? The back and the front will be the same. All right. Now, what if the force applied will be equal to frictional force? If I pull a force that more than 5 Newton, so I pull it 6 Newton, what's gonna happen? It will accelerate. If I pull with 6 Newton, it will accelerate. Okay. So at the back, I am not going to explain into detail, right? I don't want to explain into detail. I will send this one into here. If you are interested, you can go and watch the full version one, right? Here, I send into here. You can go and watch the full version, but it is in Mandarin. I explained this one in Mandarin, and my Mandarin class will be on Thursday. Right? If you want to join, after you join the English one, you don't really understand. You want to teacher, I want Mandarin one. Yeah, okay, yeah, come. Right, you can join both. Now we go back to here. Now for this question, so here 15, here 10. So that is a resultant force. So when the friction, right? No, not this one. When this force is more than this, it will accelerate to the right. Am I right? Now, when here, this one and this one, it is the same, right? We call it as constant velocity. I don't care how much it is, constant velocity. So it will be same. This force is 10, so this force is going to be 10. So F going to be 10. Alright? Now, find the acceleration of the 2 kg object given the frictional force is 10. Alright, I am going to label the frictional force as 10. You see the force is applied, 20 Newton is applied into this direction. So this one will be my frictional force. How much is the frictional force? They said frictional force is 10. Right? So now F is equal to MA. F F 20 minus friction, right? Big minus small. Now, will the frictional force more than the force? Yes, the frictional force more than this one, then it will not going to move. So this one, it is going to accelerate. So this 20 must be more than the friction. Right? So now 20 minus friction. Yeah, yes, your school teacher might not using this symbol, right? They will normally write the full name friction. Because of I am lazy, so I'm using this one, right? I told you why I am using this one already. Senang, right? 2A. Acceleration is don't know, right? And then the frictional force, how much? They said 10, right? So 20 minus 10 is equals to 2A. 10 is equals to A. A is equals to 5. Right? A is equals to 5. So, this one mean if this friction is 10, right now, here it is 10. Now, what do I do is I push with 10. What happened? What happened? It is going to move with constant velocity. I repeat one more time. If the friction is 10, then I pull with 1, not going to move. 2, no. 3, no. 5, no. 10. Then it start to move. Then it will move with constant velocity. Alright? If I push with 11 right now, then it will start to accelerate. Maybe 0.1. Right? I don't know. I haven't calculated yet. Right? 11, 12, 13, 14. Then as long as it is more than the friction, then it start to accelerate. Are you okay with this? So it will accelerate. Okay. Okay. So far, so good. Any question from here before I continue? Hopefully no. So we continue from here. Now, example number 7. Example number 7. Find the acceleration of 5 kg object when the frictional force to the rough surface is 5. They told you the rough surface friction, it is 5. So F is equal to MA. Now, here. Before we see where is the friction force, now we see where you pull here with 10. I pull here with 30. Meaning that where is the resultant force? So the bigger force is going to the right. Right? Because 30 minus 10, I told you, the bigger minus smaller one. So the resultant force is going to the right. So the frictional force will against the resultant force. So where is the resultant force in this case? It will be here. Wait. The resultant force will be here. In this direction. How much? I don't know. Yeah, I know. Wait. But I said don't know yet. Yeah, I know how much. It is 5. Here, 5. Okay. I repeat one more time. Now, let's say I use another one. Let's say same thing. Right? Here 10. I pull here with 10. You pull here with 30. Now, another guy come to pull here with 40. So this object is going to move to the left. So Now, that is a frictional force on the table because it is rough surface. So how much is the frictional force? 5 Newton, yeah, but it is into this direction. Just now, Cikgu, you said come into this direction. Yes. But if there is more force, go to the left. So compared to the right, so it will against the force go to the left. The frictional force always against your movement. Okay, make sure you know, it can change direction. F is equal to ma. So the F here, it is 30 minus 10. And then minus frictional force, right? Minus friction. Minus the frictional force. Frictional force, it is, here, I put as mu first. Actually, it is 5. Right here, 5. But never mind. ma. M is 5. A, I don't know. Alright, find the acceleration. 30 minus 10 minus 5 is equal to 5a. 30 minus 10 left 20. 20 minus 5 left 15. 15 divided 5, it is 3. 3 ms negative 2. Okay. Are you okay with here? Should be okay, huh? If you got question, just question me. Alright, no need to worry. Just question me here. I'm okay. You can question me anytime into the chat box here. Now, yeah. For those who like, Cikgu, why my video it is blur? Alright, so here. Yeah. Here, there is a button. Sometimes some student teacher, when I watch your video, it is blur. Cannot see anything. Alright. So you can go to the setting and then you go for the quality here. Quality. So you can adjust this one or this one or this one or this one or auto. Right? Until it is sharp. For example, I put it to here. This one. Yeah, can. Right? Some of student they use like for example this one blur. You see blur. So blur. Cannot see right? Cannot see. So you try to adjust the quality here by using the clearest one. Okay? Make sure if you blur then you don't know, you tell me. I teach you one more time. You go to the setting. Find the best resolution. Okay. Now, next one. Example number 8. Alright. So you got 10, you got 20. So both are going to the right with rough surface. So the frictional force here, it is 5 Newton. So because of this one go to the right, this one go to the right. So my frictional force will go to the left. Okay. So I label my frictional force first. The frictional force here is 5 Newton. Alright. I just write 5 Newton frictional force. I don't want to write mu already. Right? You know it already. Okay. So find the acceleration. Right? F is equal to ma. F is 20 plus 10. 20 plus 10. Minus the thing that against you, 5. Right? It is 30. Total go to the right, it is 30. Right? This one is against the 30. It's equal to ma. Ma is 5a. Right? So 30 minus 5 is 25. 25 divided 5, it is 5. Answer is a is equal to 5. You can use your calculator. I think this one is simple mathematics. You should be okay. 20 plus 10 minus 5 equal. And then divided by 5 equal. It should be equal to 5. Unless I calculate it wrongly. Right? Alright. I hope you're okay. Now we continue with this. Now, here. The object is pulled with 15, move with a constant velocity 3. When it is pulling, force increase to 25. What is the acceleration of the 2 kg object? So answer is 5 ms negative 2. But how to do it? Okay. Okay. Now, here, there is a information for us. This sentence. When object 2 kg here, this 2 kg here, I pull with 15, it moves with constant velocity. I pull with 15, so meaning that here there is a friction, right? I pull with 15, so it moves with constant velocity. So how much is the frictional force? Answer me. I pull with 15, it moves with constant velocity. I pull with 14, maybe it is not going to move. I pull with 12, it is not going to move. I pull with 10, it's not moving. I pull with 16, it's accelerate. But I don't want. I just pull with 15. It moves with constant velocity. So how much is the frictional force? Frictional force. Answer me. How much is the frictional force? How much is the frictional force? Answer me, how much is the frictional force? Come on. Frictional force going to be? How much is the frictional force? Frictional force going to be 15. You don't need to calculate, right? If you calculate, also can get it. But you just 15. Alright. So this information gives us the frictional force is 15. So now the force applied, not 15 already, it is 25. 25 minus the frictional force. The frictional force is 15. 15 is equal to MA. M is 2. A don't know. Right? 25 minus 15, it is 10. 10 divided 2, answer A is equal to 5. Are you okay with this? Okay. Okay, I hope you're okay. Now, here, we do some objective question together. Diagram 10 shows a horizontal force acting on the acceleration motorcycle. So all these are stat paper. The past stat paper like Kelantan, like Sarawak, got Sabah, got Melaka, got KL, got Perak, got many lah. Alright, I just pick up some only, not all, because of too many. And then second thing that I want to tell you, if you join my class, right, this notes is for you, right? So you no need to buy any other reference book already. My notes is cover everything. My notes got a lot of exercise you cannot finish one. I tell you honestly, none of my students can finish it. So this one consider more than five years of question. Right, you want to finish it? Yeah, you want to do extra one unless you can finish my question. If you cannot, you don't need to buy. Honestly, you don't need to buy one. You buy, you cannot finish one. I tell you honestly. Alright. Now, diagram 10 shows a horizontal force on the accelerating motorcycle. So that is the force forward. Forward force, we are going to call it as thrust. Thrust. Right? Thrust. And then air friction. Air friction is another friction. Air resistance is another friction. So which one is true? So the resultant force is not 0. Yeah? If the resultant force is 0, it is not going to accelerate. So number 1 is correct. Number 1 is correct. Here, number 1 is correct. The thrust is the forward thrust. The thrust is equal to the air resistance. No. Yeah, correct, but no. Why? Because you still got friction here. The thrust should be equal to friction plus air resistance. Baru betul. Right? So this one is equal to this one. Needs to get this one. The friction is tire. Something that uh we call this geseran. Geseran. Daya geseran. Friction. Right? You got something that rubbing each other. Right? Air resistant it is another kind of friction, but it is not frictional force. It is not like the one that touching the ground one. Okay. The motorcycle is not in equilibrium. This one is wrong. Number two is wrong. Number two is wrong. Number two is wrong. Number two is wrong. Number one is correct. Number one is correct. Right. Number two is wrong. So left number three only lah. But never mind. The motorcycle is not in equilibrium. Yeah. Equilibrium, constant velocity. So this one is not in equilibrium because of it is accelerate. Yeah, number three, it is correct. 1 and 3. So air resistance plus the frictional force is equal to the is more than the thrust. No. Okay. Equal to the thrust also no. The thrust is more than. This one is baru correct. Why? Here, this one, let's say 10. Right? This one is 2. This one is 3 Newton. 10 is more than 5. Yes. So it accelerates. You said that this one plus this one is more. Then what does that mean? So this one 13. This one 12. 13 plus 12. 25. 25 more than 10. Will it accelerate? Cannot. Because the one that pulling you, it is more than your thrust. So it is not going to move. Is that okay? Is that okay? So answer is 1 and 3. Answer is B. Okay. Now, when the object has a zero resultant force, the object will be must be stationary. No, not necessary. Can be moving. Must be moving with uniform velocity. Can be stationary or moving with uniform velocity. Is either stationary or moving with uniform velocity. Yeah. Is either moving with uniform velocity or moving with uniform, not acceleration. No. Okay. C, yeah. Answer is C. This one I haven't teach you, but you can do lah. This one you can do. I haven't teach you yet. Alright. I'll teach you. Wait. This one is page 8. I'll teach you about at result equilibrium. Somewhere here. Oh, let me see. Wait, I accidentally put it here. But actually, I'll teach you after, like here. Here. Somewhere here. At page 20 something. 20 something. So a person inside the lift, what gonna happen? And what is that force called? Like what I told you just now. Like what is this one is called thrust, this one is called drag, this one is called lift, this one is called weight. Yeah, that is another name. It is a specific name for it. You need to memorize one. Right? But now we leave it first. Right? I am going to come back to do it. But never mind. I just do it. Which one the force it is correct? So this one, the lift is moving upward. Moving upward mean moving upward with constant velocity. Constant velocity mean up and down it is the same. Right? R is equals to W because of constant velocity. Equilibrium. Answer is B. Answer is B. Right? But I haven't teach you. So you can do it also. Alright. Next one. Diagram 30 shows the stationary. Stationary means not moving. Alright. So up and down will be the same. Left and right will be the same. So 3 is equal to 4. 3 is equal to 4. Yeah, correct. 4 more than 3. 4 more than 3 mean it is going to move to the left. 4. Force 4 is more than force 3. Force 4, you see the direction it is here. Force 3 is pushing it here. Let's say this one pushing it is 10. This one pushing it is just 2. So it is going to go to the left. So it is not stationary already. Okay? When F1 more than F2, F1 more than F2, then it will go up. F2 less than F1, then it will go down. So answer will be A, equilibrium. Yeah? Stationary or uniform velocity. Be careful. Now next one. A constant force of 35 Newton act on the block placed at the rough surface shown in the diagram 12. If the friction it is 5 Newton, the block will move with. Here, you push with 35. There is a 5 stop you. So, what happened? What happened? It is going to move to here, right? With acceleration. We call it as constant acceleration. It is not increasing acceleration. It is constant acceleration. Because the force that it push, it is constant force. Wait. A constant force. So the acceleration will be constant. If the force is increasing force, of course this one acceleration will be increasing. Alright. So if they don't if they don't say constant force, they just said force, right? Then what will be the answer? So answer still constant acceleration, because the one that we learn in Form 4 and Form 5 is only constant acceleration. All right. So answer is B. Answer is B. Okay. Now, this kind of question. Never mind. We do it. Right. 2023 Malacca. Diagram 16. I make it bigger. Diagram 16 shows the two pupil pushing a large box with the force 1 and force 2 respectively. Magnitude of the force 1 and force 2 are the same. The box is in equilibrium. So F1 and F2, it is the same. Right? So meaning that F1 going to the right, F2 going to the left. Right? F1 is equals to F2. Answer. F1 is equal to F2. F1 is equal to F2. Don't have a cikgu. Right? So we are going to take this one as vector. This one, they actually put it into the wrong way. They have to put it in the vector way. Vector way is meaning that I move this one to here. F1 minus F2 is equal to 0. Right? And vector, you have to have the direction at here. F1 minus F2 is 0. F1 minus F2. F1 minus F2 is 0. F1 minus. Answer is B. F1 minus F2. Because F1, we are going to take it as a right. Of course, you ask me, Cikgu, how about this one? I bring this one to here, leh? Alright, 0, F2 minus F1 F2 minus F1 is 0. Boleh but here, F2, we said this one F2, it is going to the left. Left, normally, we are going to take it as negative. You need to know. Going to the left, we are going to take it as a negative. Right? Going to the right, we are going to take it as positive. Right? So this one means left, it is negative. F1 is going to the left. No. Right? Of course, mathematically, it is correct. But if you put it into vector, it is wrong. Because of the direction terbalik. Right? Answer will be B. Answer will be B. Right? So the correct way to write it, I tell you first, the correct way to write it is F1 here, vector. You can write F1 minus F2 is equals to 0 vector. Or this way, F1 here, like that also can. Vector. They didn't write it. I said this question not so good lah, but anyhow, still can answer. This one I haven't really do it, but never mind, we try to answer. Diagram 12 shows three forces acting on the object, which representing the magnitude and the direction of resultant force of the object. So this one is 2, this one is 6, meaning that you got a resultant force. So here 2, here 6, so you get the resultant of 4. 4, here 3. This one is 4. 4. 6 minus 2, 4. This one is 3. So what is the resultant force? Here and here, Pythagoras said it's gonna be here, 5. Right? 5 here. Going down, going to the right, so it is going to go down. Right? 5. Answer is B. Of course, you ask me, Jegu, how do you know this one go up or go down? Right? So you pull to the right because of this one and this one. So we got the resultant going to the right, 4. Now this one going down, 3. This one going right, 4. 3. If you draw the triangle, this one is 3. So this one is from where we start to where we end. This one is called the resultant force. 5. Okay. Alright, so we try to look at this question. The situation below shows a tug of war, which situation produces 0 resultant force, right? At 100, 900, no. 900, 800, no. At yes. 750, so answer is this one. So the magnitude have to be the same and the direction have to be opposite. It will give me the resultant force 0. Okay. SVP 2024. Diagram 17 shows a car applied with a force F moving with constant uniform velocity. Mean F and frictional force is the same. So what is the magnitude of F? Same as the frictional force. Same as the frictional force. Equal to the frictional force. Why? Uniform velocity. Right? Equal to the frictional force. Okay? So easy, right? If not, you need to calculate. Right? So if you understand this, what is uniform velocity? What is equilibrium? What is 0 resultant force? So you don't need to calculate. This one actually I haven't really teaching you yet, but never mind, we still can answer lah. Which diagram shows the sum of the force 6 Newton and 8 Newton? I haven't teach you. I'll come back to do this question. Okay or not? Yeah. I'll come back to do this question. Yeah. I'll come back to do this question. Because of it is confusing with another one. Right, this one I am going to skip first. This one I skip first. Number 30 I skip first. I'll come back to do it again. This one I also, because of you see later we are going to learn it. Not today lah, of course. Maybe not today lah. Today not enough time to cover until today. But anyhow, you still can answer. So which statement it is correct to explain the force acting on the aeroplane? So the aeroplane, it is moving forward with the acceleration with constant attitude. So what is constant attitude? Constant attitude means it is not going to go up or down. It is going to the moving to the right with the thrust force, moving forward. Right? So constant attitude, the attitude it is constant. So it is accelerate to here. Mean forward thrust is more than the drag. Forward thrust is more than drag. Forward thrust, it is more than the drag. So that it will accelerate forward. If it is not going to accelerate forward like helicopter, it is going to go upward. The lift is more than the weight. Okay? But this one, the lift is equal to the weight. I write here. For this case, lift is equals to the weight. So answer here, it is forward is more than the drag. Forward thrust is more than the drag. Of course, you ask me, teacher, what is drag? Later. Not today. Let see maybe next week lah. I try to. Ayo, so many. So this one I put it as your. I see got many or not. 1, 2, 3. Not many lah. I finish it. Right, I finish it. Few questions only. Ayo, quite many. Okay. Okay, number 22. Diagram 12 shows some cyclists during a race. Which of the following is a method to reduce air friction? Wearing a fit attire, wearing a helmet, wearing a glove, wearing a big size of wheel. So this one is wearing a fit attire. Why? Because of you, if you wear the baju longa, then there is a lot of air stop your movement. Right? So your friction will be big. Air friction will be big. So you wear tight fit, so they will reduce the friction. Diagram 11 shows the three horizontal force acting on the car that is moving along a straight level road. So which combination result in the car moving at constant velocity? Constant velocity means left and right will be the same. So forward here, this is forward thrust. Thrust 1005. So with this one 1005. So here have to be 1005. 1500. 1500. Yeah, correct. A is correct. Teacher, how about B? All right, we try to have to look at the B. This one 1500. Right? For thrust, thrust is 1500. This one 500. This one 500. Where got the same? 1000. This one 1000. This one 1500. Have to be 1005. 1005. Then it will move with constant velocity. 1005 forward. So this one 1000 plus 500. 1500. Okay. Answer is A. Number 13, I haven't teach you yet. I skip this one. I'll skip this one. Alright, this one I haven't teach you. I need to teach you how to draw. Not today. Number 21, diagram shows a ferry accelerating at the Penang seawater. Which of the comparison it is correct? So this one accelerate. They said accelerate. Accelerate means forward thrust is more than the drag. F1 is more than F2. F1 is more than F2. The keyword here is accelerating. If it is meaning that constant velocity, not accelerate, constant velocity, F1 is equals to F2. This one is not constant velocity. This one is accelerating. Okay. All right. So we continue. Diagram shows the two forces acting on the object in the opposite direction at and 6. So which of the statement is correct? Where method to calculate between two forces, right? So the direction of the resultant force is magnitude without the direction of force. The direction of the resultant force is the direction of force without magnitude. The resultant force is expressed without giving magnitude and direction. The magnitude of the resultant force obtained from the vector sum of two forces or more. Alright, answer is D. Right, from the definition. Right, early from the definition, then we already got. Okay. Alright. So we continue. Wait, eh? Uh, wait, oh, okay. Any question from here? Any question from here? Uh, okay. I let you try to do some question. We rest for like 5 minutes. Normally after 1 hour, I will like give you to rest for like few minutes before we continue. Right? So we rest for like 5 minutes, 5 to 10 minutes lah. So if you don't want to rest, you can try to do question number 25. You try to do question number 25. Here, this question, page 17 until 2 question only lah. Page 17 until page 19. No, 18. 2 question only. 2 question. 25 and 22. Alright. I am I am coming back after we rest for a little while. Alright. I'll see you later. See you guys later. Alright. Be right back. All right, I'm back. So let's continue. Okay, now question number 25. Trust. How much? The trust here 500. So this one is more. No chance. All right. So we take D. Take D. All right. Take D. Here it is 1,500. Thrust forward is 1500 Newton. Here it is friction. Friction is 500. Here it is 1,000. Right. So total 1,005. So it will move with constant velocity. Yeah. Constant velocity. Yeah. Answer is D. Answer is D. I said D. What am I doing? Answer is D, yeah. Okay. Now, number 22. Which diagram 15 shows the three horizontal force acting on the racing car that's moving along a straight road. So, which combination of the force would result in the racing move in uniform velocity? Mean left and right will be the same, right? Left and right will be the same. So we choose the bigger one. Thrust 1002, 1002, 500, 500. It is not 1200. So this one out. This one plus this one, 1200. Yeah. A, answer. Answer is A. Are you okay with this? Meaning that here 1200, this one air friction is 650, the frictional force is 550, plus together 1200. All right. So we are going to move to this one. All right. Next one, example number 10. This kind of question is consider got angle one, right? Just now, what we learned is here the one with resultant force, constant velocity, or you got an acceleration one, or you got these four cases are situation 1, situation 2, right? Same direction, opposite direction. And then this one we also do it, right? Perpendicular, which is Pythagoras theorem. And this one it is you need to use sine rule or cos rule one. Okay, so we go to here, example number 10. Now you see this one, it is not right angle, it is got angle one. Okay, by drawing a diagram, find the magnitude of resultant force, find the direction of the force, find the acceleration of the object. Okay, now first of all, I draw with using freehand first, and then later I'll draw it one go. All right, so here you see this one, it is where you start here, you go to here and here. So you need to draw a parallel to 10 Newton here and parallel to 15 Newton here. So your force is from here to here. This is the resultant force from where you start to where you stop. Okay, so we draw in one go. Okay, like that. Well, okay, right. So I label the 10 Newton here, 10 Newton here. Here it is 15 Newton, here it is 15 Newton. So the resultant force is from here to here. All right. So normally resultant force, we are going to use two arrows. Right. I called it as FR. Resultant force. Okay. Now I have drawn it already by drawing so magnitude of the resultant force. You want to find this resultant force. So now first of all, you need to have angle, right? Angle. So this is the angle that I want, right? So here, this one, it is 30. Meaning that here it is meaning that here it is 30. Meaning that here parallel, meaning that here it is 30. If here is 30, mean here it is 150. 180 minus 30, 150. So I put it in 150. This angle in already. Now we are going to use this one. We are going to use cos rule, right? Sine rule or cos rule, but this case we are going to use cos rule, cosine rule, right? Cosine rule. So cosine rule. I don't know whether you learn in maths or not. The formula is a square is equals to b square plus c square minus 2bc cos a. Do you learn this? Do you learn this formula in MS or I think MS lah? Do you learn it? Yes or no? Do you learn this one? Have you learned this formula? No, you also need to know because of you are going to learn in MS soon, right? Maybe lah, or last year you already learned it. So this one's 15 square plus 10 square, right? So now, first of all, you take it into this way. This one is 15, this one is 10, here is 150 degree. So you want to find this one, right? This one, FR. FR square is equal to this one square plus this one square. Two side square. Two side, this side and this side square, right? So FR square is equals to 15 plus 10. 15 square plus 10 square minus 2 times this one and this one. 15 and 10. Cos the angle 150. So you press the calculator. You press in the calculator. 15 square plus 10 square minus 2 times 15 times 10 times cos 50, 150 equal. So this one is square. So I need to square root. So to get 24.18. Unit Newton. 24.18, yeah. Using cos rule, cos rule. This one seldom come out, right? Because it is kind of like at maths, right? Normally when they come out, they just ask you, objective, they just ask you, where is the direction? That's all. Where is the direction? Direction of the force. Alright, so you need to find this angle for me. Alright, I want to find this angle. Okay, so now here I'm going to put in this angle. Alright, this angle is B. Sine this angle to this is sine this to this, right? Sine rule. Sine rule, we are using this one is equals to sine theta over the opposite. Sine theta over the opposite is equals to sine 150 over FR. Right? Sine 150 over FR. FR we know it 24.18. Okay, so we can find the theta 24.18. Sine 150, sine 150, sine 150 divided by sine 24, not sine, sorry, 24.18. This 10 come to here, become time 10. Is my sine theta. So I shift sine will get my answer. Right? One more time. Sine 150, I'm sorry, sine 150 divided by 24.18 times 10. Then I shift sign equal 11.93. Theta is 11.93. 11.93, yeah? 11.93. Unit is degree. That's all. Okay, you use sine rule to get this. Have you learned in MS? I guess you already learned in MS, right? I hope so, huh? See. Acceleration of the object. Acceleration. So acceleration F is equal to ma. F. This question they don't give you frictional force or what, so we just assume don't have friction, right? If there are any frictional force, they will tell you. Frictional force 20, frictional force 5, they will give you. If not, you just leave it, right? So the resultant force is 24.18 is equal to ma. M 5. A, I don't know, right? So 24.18 divided by 5. 24.18 divided by 5. Answer 4.836. Unit is acceleration is ms negative 2. Right? This is the answer for this one. Right? This one no need to spend too long time into it because of this one you will learn in MS. Okay. How about if I got two forces, like for example, I pull here, you pull here, so the angle is 150. 10 Newton and 15 Newton by using the diagram. Okay. Draw the magnetic, draw the diagram first, right? So I draw it directly here. Okay. So the resultant force will be from here. Where do you start here? Right? Go left, go left, go right, go right. Okay. From here, where you start to where you end. Okay. Here, it is your 10 Newton. Here, it is your 10 Newton. Here, it is your 15 Newton. 15. This one is your resultant force. Resultant force. Okay. Here, it is 10 Newton. I've drawn it already. Now, letter, I want to have this angle. This angle. Right. This angle I name it theta. Letter lah. Right. Okay. Now, first of all, find the magnitude of the force. I want this force how much? Alright. So, same thing. You are going to use cos rule. Right. You are going to use the cos rule. By using the cos rule, is this angle you have to know. Right. This angle. Okay. Wait. This angle I don't know. Wait. My mistake. I need to have this angle first. Okay, I'm sorry, my bad. Right, I'm sorry. This angle. Right. So because of this one is 150, here it is 150. Here it is 150. So 180 minus 150, it is 30 here. So this one is 30 degree. The angle here is 30. 30. So using the cos rule, same. Cos rule. Using the cos rule, now opposite square, FR square. FR square, resultant force square is equals to two side square. 15 square, 10 square. 15 square plus 10 square. After you plus the square, you minus. Minus 2 times 15 times 10. Cos the angle. Cos 30. The angle is 30 here. Cos 30. So you can press the calculator to get the answer. 15 square equal. Now this one is square, so I want to have square root. I want to find FR at 0.07. At 0.07. So at 0.1, yeah, run off. They run off. Right. So I put it as at 0.074. Unit Newton. Now, of course, you ask me, Jagu, teacher, can I put this one or this one? Which one it is correct? When calculation, you put this one. But this one is normally, once they ask you, you draw this, you draw this, you draw this, you draw this, and then you draw this. You measure how much it is. You cannot measure until that accurate one. So you agak-agak like at 0.1 cm. So that's why you get at 0.1 Newton. Right? At cm or at 0.1 or at 0.2 like that. You can measure until there. So you cannot measure at 0.074. But by calculation you can. By measure you cannot. Because of this one, they ask you to draw. They never ask you how to answer. Either using calculation or either using drawing, measure. No, they never ask you. So you can use calculation. Okay. So now direction of the resultant force. The direction of the resultant force is here. Right here. So you need to have this angle right now. So this angle, I put it as theta. Okay. Here it is theta. Theta. So find the theta. Sine rule. So this one we are going to use sine rule. Sine rule. So this one is opposite, right? Sine theta over opposite. Sine theta over the opposite. Opposite is 10. Is equals to sine 30 over opposite. Sine 30 opposite. Opposite is FR. FR is this one. Okay. So because of this one, I didn't round off. Like not like this one, we round off. So the angle will be slightly different. Right? But it is near to 38 lah. Now sine 30 divided by this one at 0.074 times 10 equal. Then shift sine 38.26 degree. Theta, the angle will be agak 38 there. Okay, the acceleration finally. See, they will ask you acceleration. F is equal to ma. F is equal to ma. The resultant force, how much? We have calculated at 0.07. Is equal to ma. M is 2 kg. Alright, so divide by 2. At 0.074 divided by 2. You get 4.037. 4.072. Now, here 4.05 because of they round off. Here, 8.1, you round off, you divided by 2. 8.1, you get 4, sorry. You get this. Because of they use this one. Alright, so my one is more accurate, so my answer will be slightly different. Right, so this one, it is how you get the direction. So more important one, you will see they will not ask you to calculate because of this one. If calculate, it take a lot of time. First one, and then second one, where it is going to come out. Essay, no. Essay normally writing table one, no way to come out. Objective, yeah. Objective, it asks you this one, a bit hard lah. But anyhow, you learn lah. I just give you 2 examples of it. Alright. So we move to the next part. Alright, next part. Resultant force of the object in various state of motion. So Newton's third law said that for every action there is a reaction with same magnitude but opposite direction. This one, it is also you have learned it in Form 4. Form 4, which is impulse and impulsive force. There. Impulse and impulsive force. For every action, when you kick it, you kick a ball, your action is the force that you kick the ball. Right? So there is a reaction, terbalik. Right? Same magnitude, but opposite direction. Okay? Here, we go see revision in Form 4. Wait. Impulse and impulsive force. Okay, here. Okay. Newton's third law. For every action, there is a reaction of equal magnitude but opposite in direction. So this one, I Form 4, I taught you a little bit right? But now we are going to go into detail, right? Okay, now here, so now every object that is stay at rest. So here, this is the object you put on the table. You put on the table, that is the force acting downward, always going down. It is called W. W is equals to formula mg, if you want to know, right? You have learned in form 4, right? So this one is the force that we are going to learn right now. It is called normal reaction, right? So you can just call it as normal. You can just call it as reaction. You can call it normal reaction, right? Normal reaction, R. R stand for reaction, right? Some of the teacher will like write this one as N. N stand for normal. It is okay, right? Normal or normal reaction, it will be okay. Now, if it is stay at rest, mean not moving, mean equilibrium. Mean equilibrium mean up and down will be the same. R is equal to W. Okay? R is equal to W, equilibrium. For the object that is hanging at rest, okay? Now here, this is called tension of the rope. We normally use the symbol of T. T. Only 4 situations you need to know. So this is T, this is W, right? T is equal to W. Okay? The second situation, right? Third situation, it is here combined. So the object that is moving, all right, moving, this one is direction of motion. So the trolley here, so that is the W, that is R. Teacher, how to differentiate R and T? T is something hanging, tension of the rope. Right? R is you put on the ground. You stay on the table. You got touch, contact with the ground, table, all this. Not something hanging. Okay? So here it is W, here is R. W is equals to R. W is equals to R. Constant velocity also can, acceleration also can, I don't care. Because of this one, it is not going up, not going down. It is going to left and right. Okay? So R must be equal to W. Now, if the object move with constant velocity means the forward and the backward will be the same. T is equal to mu. T is equal to mu. Constant velocity. If acceleration means forward force is more than the frictional force. Forward force 10, this one add, then it will accelerate because of you got the resultant force. So it will accelerate. You get it? Now the third case, the last case is the object that is 1, 2, 3, 4. This one is the extension of the fourth case, right? Here. Now you got an inclined plane right now. This is your inclined plane. The object that is stay on the inclined plane. So the weight always going down. The weight is always going downward. Weight is always going downward. You don't need to draw. I have drawn it already for you. Right? W. And then the R always 90 degree to the surface. Right? Like just now, the R is here. R is 90 degree to the surface, 90 degree. Here, that is your surface. Here, this is your surface. So 90 degree to the surface. This is called R reaction. Reaction, So this one, the object, it is going to slide down. Slide down. So why? Because of that is a weight. Pull it down. So we call this component of the weight down the plane. Component of the weight down the plane. And then lastly, this is a frictional force that stops the object from moving downward. Okay? Now, the one that you need to know is this anchor. This anchor is very, very important. This anchor is theta. If you print the knots out already, then you can put it in. This one. This theta is equal to this anchor. Alright, I repeat one more time. This anchor is equal to this anchor. Always the same. Now I explain to you why. And then next time, we are not going to explain already because of it's always the same. For example, right here. I take this one as 30 degree. Yeah, let's say 30 degree. Now this is the weight going downward. This is the reaction going this way. Here. What is this angle? 30. Why? Teacher, why 30? So this is 30. This is 90. Because of right angle. Right? 180 minus 30 minus 90. Left. Minus this, minus 120. Left 60. Meaning that this angle is 60. Right? And then this one, you know that it is 90 degree. So 90 minus 60 left 30. And then this one 30, 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 this one 30. Eh, same oh. So lucky it is the same. Never mind. We try one more time. I'm not happy with this. Teacher, how about this one 20? Okay. 20. This is W. This is R. Okay, this is 90. 180 minus 90, left 90. Minus 20, left 70. Right? 90 minus 70, left 20. Right? This is 20, this is 20, this is 30, this is 30, this is 40, this is 40, this is 80, this is 80. So this angle always same as this angle. No why, it is memang like that. Right? Don't ask me, teacher, why this one theta again? No, just the same. Right? It is the same. You calculate 1000 times, it will be the same. Right? No need to calculate. And we know that if this one come to here, and this force will be the same. This force and this force, equilibrium, they will be the same. This force and this force will be the same. Right? So, first of all, R is equals to W cos theta. Why it is cos theta, I will show you where to memorize it. Right now, you need to memorize. Because of next week, we are going to do a lot. Right? Wait, I will show you how to memorize. Now, F is equals to mu. Right? F down here is up here. F is equals to mu. No problem. This one. Right? Constant velocity, not moving. Or if it is accelerating downward, F is more than mu. Right? This one. Okay. Just this one, I need to tell you how to memorize. Before I teach you how to memorize, I teach you how to understand first. And then after that, I am not going to use that way. Okay. Now, I use this triangle. I draw this triangle. This is theta. This is W. Right? This is, I don't know. And then this one is, so I want this. All right. I put it as X, okay? Now, cos theta is equals to, this one is adjacent, this is hypo, right? Cos theta is adjacent over hypo. So W go up. W cos theta is equals to my X. So this X is equals to W cos theta. I repeat, cos theta is adjacent over hypo. Adjacent is X, hypo is W, right? W go up, X is equal to W cos theta. Now, okay, this is how it comes from. But now I want you to forget about it. Don't memorize it. Now, how do I teach you how to do this one is, you bring this W to here. You see, I bring this W, touch theta. You see the red one touch the theta or not? Yeah, touch. I use cos. Okay. Touch. Not touching. Use sign. Okay. I repeat one more time. when this W come to here, teacher, what is touch? Okay, you see this theta here, this theta, the red one, it is not this one, not this one, right? Not this one, So the theta here, W bring to here, touch theta, I use cos. Touch, I use cos, right? If this W I bring to here, not touching, I use sine. I bring to here, I use sine. I bring to here, I use cos. Touch, I use cos. Not touching, I use sine. Right? So this one we are going to go into detail again. Okay? When we do exercises, we do example. Where is the example? Not today lah. Today not enough time. Somewhere like here. Like here. Next week lah. Here. Here there is a lot of example here. Right? No. Wait, we better finish this one first. Okay. Now the last part. The last part is teacher. Sometimes there is the object that's hanging on the in the sky. Correct. So for example, aeroplane. Aeroplane you flying at the sky. So there is no tension, no string to hang it. Tada tali, no tali to hang it. So no tension. There is not touching the ground, no reaction. So we call this one as lift force. This one we call it as lift force. Lift force. Lift force, it is not touching, not hanging, no nothing. It's still going up. That one is called lift force, right? Or sometimes they don't call it lift force. They can call it as upthrust. They can call it upthrust also. Upthrust also can. Lift force and upthrust. Okay, the one that going down, it is called wet as usual. We know it as wet, right? Now, the one that forward here, it is called forward thrust. Or sometimes they can call it engine thrust. Forward thrust, engine thrust. And then this one, G. G is the name for drag. The drag including all the air friction here. Air friction. The drag here is air friction. So now you need to read this question properly. For the object that is flying constant velocity and constant height, meaning that this aeroplane, it is not going up and down, left and right. Left and right will be the same. Up and down will be the same. Okay. Left, up and down. W is equal to L. W is equal to L. W is equal to L because of it is constant height. Right? T is equal to G. T is equal to G. Right? T, the thrust engine, is equal to the G because of constant velocity. It is moving right with the constant velocity. Okay? Now, what if the aeroplane, it is accelerating? Accelerate means shoo. Forward thrust is more than the drag. T is more than G. T is more than G. Okay? And then increasing altitude. Increasing altitude, I mean L is more than W. L is more than W. Okay? This one you need to know, This one you need to know. Okay. I do few one or two to three example easy first, right? To show you what is teacher, what is this? Okay. Now you need to know label all the force acting on the object and then find the normal reaction. Okay. So here that is a force going down. We call it as weight. This one we call it as reaction. This is called W. This is called R. Make sure you know how to label it. Direction must be correct. If you draw it wrongly, you cannot answer. Okay. Now, this one is not moving, right? Stationary object. You put on the table. How can it move, right? You don't push it. How can it move? So, W is equal to mg. W is equal to M. M is 5 kg. G is 9.81. I lazy to press calculator. So 5 times 9.81 is 49.05. You press, you will get it. Right? So this is how you get the reaction. Alright. Alright. The first question, very simple one. Now, the rough surface here, the direction of motion here. So label all the force. Okay. So that is a weight going down. That is a reaction. So that is a forward thrust. Teacher, how do you know it is forward thrust? Because of you move forward. If you don't move forward, how do you have thrust? If you don't have thrust, how do you move forward? So this is the rough surface, mean you got the friction, right? So I label all the, this one R, this one is W. This one normally we name it as T lah. This one like what I told you, if I write here, it will be frictional force. So because of frictional force very long, when you want to write equation so hard, so we will write mu. But anyhow, in your exam, your school teacher don't use the mu, right? So you choose yourself, you want to write it as mu or you want to write it as frictional force. If school exam, I will prefer you to write frictional force. If you calculate on your own fast, then you just write mu. Senang. Find the normal reaction. So this thing, it is going up or going down? No, it is on the table, it is on the ground. So R is equal to W. R is equal to W. It is not going up, not going down. W is equal to mg. M is 2 kg, right? M is 2 kg. G is 9.81. 2 times 9.81, 19.62. You need Newton. I repeat, R is equal to W. Because of this object, it is not going up or not going down. So R is equal to W. If the trolley is pulled with 12, here 12, right? Frictional is 3, okay? F is equal to MA. F, the resultant force is 12 minus 3. Here, this one is 12. This one is 3. Right? 12 minus 3. Is equal to MA. MA is 2A. Right? So I want to calculate the A. 12 minus 3, 9. 9 divided by 2, 4.5. Unit is MS negative 2. Right? This is how you get it. E. Okay? Similar to what we have done just now. Right? Just the direction is small. Right? Yeah, it's small. I do one more example. Very fast one. Well, I see. I see I should do it or not. No lah, no lah. No. Why? Because of this example and this example letter, it is related. So I do it next week. Okay. Anyhow, you can ask your friend to join. I send the link to you. Wait. And then next week, I plan to do one. I plan to do one. What's that called? Later I tell you lah. This one, it is the Google form. This is a link. Right? You ask your friend to join. Ask them to join the tuition. Ask them to fill this form and then ask them to write your name. If they write your name under the referral, you got 10 ringgit rebate every month. Right? Next week, I'll plan to do one lucky draw for you. Ask your friend to join. You will get they will get the lucky draw, right? I'll tell you what to do, and then lucky draw, mana tahu kena you leh. You got ang pao for Chinese New Year. Okay? This one not for 1 month only. It is every month. every month 10 ringgit. If you invite 10 friends to join, you got 100 ringgit rebate for every month. Your tuition fee only 65, so you got 35 extra income I pay you. All right, okay. Ask your friend to join. Make sure you ask them to write the referral as your name. Any question before I end the class? Any question before I end the class? You can watch the first video that I tell you if you understand Mandarin. Right? If you want to join again, Cikgu, I want to join on Thursday. Okay, no problem. Thursday, you after join the Monday one English version, you want to join the Thursday one, okay one, you can join both. Right? Is that okay? Right? I am Mr. Lee. I am going to stop here. We are going to continue next week. All right, bye bye. Next week I do lucky draw for you. Right? Bye bye. Good night. Help me to press like button. Thank you. The like, the thumbs up. Thank you, everybody. Thank you. See you. Good night.